All right, we're back. We're going to talk about symmetry real briefly. With symmetry, this is probably the easiest topic out of all of the things that we take a look at. The best way that I can describe symmetry is in two different ways. So with symmetry, what most people tend to think of when we talk about symmetry is just the fact that you can either have the same thing on both sides of a mirror, right? It's symmetric. So if we drew a line, in that line on both sides, we would have the exact same shape. So right here in this example, this is the line symmetry. Okay, we're going to draw a line, and whatever line that we choose, okay, we're going to end up with the same shape on both sides. So if I were to take this line right here and call this my line of reflection, and pretending that this was a piece of paper, if I were to fold my piece of paper and take this corner right here and fold it over the top like this, so I'm folding it along this line, this is my fold line. Okay, this point, this blue point right here is going to come and match up perfectly with this point. And this is what we call mapping a figure onto itself. Okay, so if there was a point that was, let's just say, right here in the middle of this line, okay, if I were to fold it, okay, it would be mapped exactly to the same spot on this line. So if we continue that thought, and I fold right up here at the top, right? So I'm folding right on this black line. Okay, this top point is just going to be split in half, right? So the whole paper comes over. This top point is still going to be on top of itself. So that's what it means when it talks about mapping the figure onto itself. So line symmetry, think of a mirrored image. It's going to be the same thing on both sides of a line. One way that you can figure out whether or not something has line symmetry is get a piece of paper, and wherever you think the line of reflection is, okay, take your piece of paper, put it up to your computer screen, and then you would cover the portion that you think the line of symmetry should be, or the line of reflection should be. So if I were to take a piece of paper, I would take my piece of paper and I would cover this up. And with a piece of paper, it's opaque, right? So you would be able to see through it. And then you could tell whether or not, I mean, you could draw the shape out and then like trace it onto your piece of paper and then fold it that way. But you would be able to tell just by putting your piece of paper up here. If this was my line, I would only trace like this piece right here, because that's the piece that's covered up. And then what I could do is I could flip my paper over to the other side and see if this piece matches when it gets flipped over. So there's multiple ways that you can do this with a piece of paper at home. Okay, so just be aware of that. Now for the other examples, or the other types of symmetry, they're all about rotating the figure, right? So we can't physically rotate this piece of paper here, but if you have access to a PDF file, then you could rotate it using the view feature in the PDF file. I don't have that feature in here, as you can see, but basically what you're doing with your rotation, your point symmetry and rotation symmetry, is you're just turning the piece of paper to see whether or not you get the same shape whenever you turn it a certain amount of degrees. Now, with point symmetry, okay, with point symmetry, you're going to flip your paper upside down, right? That's what this little note down here says. You're going to flip your paper upside down, or you would turn it 180 degrees about a center point. And if you flip the paper upside down, you will get the exact same shape on the other side. So one easy way to think of this one is like your computer screen. Okay, you can take your computer screen and you can flip it upside down and see whether or not you get the same shape, the same letter, whatever it ends up being on the other side. Okay, so with this, okay, if you rotate it and you turn it upside down and you get the same shape, then the figure has point symmetry. With rotational symmetry, you're thinking of something like a pinwheel. You could also think of like a carousel, okay? So when you spin the shape, when you turn the shape, at some point of turning it, you're going to get the exact same shape again, okay? So this one doesn't have to be 180 degrees like up here. So you don't have to flip it upside down and get the exact same thing. For this one, okay, the best example that I can give you here is like if I drew this rectangle, okay, this is my original shape. If I rotate it, let's say 90 degrees, okay, if I rotate it 90 degrees, that's going to give me this picture. It's going to give me something like this, right? Because I took it and then I rotated it 90 degrees and it gives me this. If I do 180 degrees, okay, so I rotate it another 90, rotated it 90 twice. That's the same thing as rotating it 180 degrees. Then I will get the rectangle again. So I'll get this exact same picture. Now it's just upside down, right? And then if I did another 90 degrees, then it would turn like this and so on and so forth, right? So you can either rotate it 90 degrees, you can rotate it 30 degrees, you could do like 100 degrees, and you know it's kind of hard to figure out how many degrees you're actually rotating something when you don't have a ruler or a compass or a protractor to do it. Okay, but the point that I'm getting at here is if you just take your paper, take your computer screen, and then you move it just a little bit, or you rotate it just a little bit, and then you get the same exact shape again, okay, then that would be rotational symmetry. All right, so I'll do this with a triangle. Let me see if I've got a triangle here. I don't have a triangle. Okay, so if I have this as my triangle, right, this point up here at the top, I'm going to put it in red. This is the point that I'm focusing on. Okay, I'm going to need to get another point. If I'm rotating my shape, I need another one of these vertices, whether it's here or here, it doesn't matter. But at some point, I need to rotate this triangle to where this X ends up here at the top, or this X ends up here at the top. And it doesn't matter which way you rotate it, right? I just chose to go clockwise on this example. If you went counterclockwise, that would work as well. It doesn't matter which way you rotate it, right? So if I went this way, I would need this X to be at the top or this one. Okay, so it's hard to draw this out, but if I were to start turning my shape, right? So kind of like what we did over here. Okay, if I'm going to go clockwise, so I'm going to rotate it like this, right? At some point, this red dot, it could end up over here somewhere, right? And then I would have my shape, my triangle look something like this, right? So we can't tell if it's symmetric yet because we haven't ended up with one of the vertices being up here at the top, right? But if I rotate it a little bit more, and I keep going, right, then eventually this X right here that we started off with is going to be up here at the very top. Right, and there's ways to figure out like what the exact amount of degrees is that it turned, but we're not concerned about that. The only thing that we're concerned with is, can a shape have symmetry just by rotating it? Okay, so these are your strategies for solving these. Now, before we get into an example or two, we need to talk about what happens if we have point symmetry. Okay, so if we have point symmetry, okay, we know that the figure, when we rotate it 180 degrees, it's going to be the same. It's going to be the same shape upside down. Okay, if we have point symmetry, then we know that we have rotational symmetry. Okay, if we have point symmetry, then you also have rotational symmetry. Point symmetry, you also have rotational symmetry. Just because you have rotational symmetry does not mean that you have point symmetry. Okay, so it doesn't go the other way around. So just because you have rotational does not mean that you have point. Okay, so just because you have rotational does not mean that you have point. Okay, just because you have rotational does not mean that you also have point. Okay, so it only goes one way. This goes back to logic and reasoning. I'm not going to get into all the nitty-gritty details of it. Okay, but if you have point symmetry, okay, based on the definition of point symmetry, you're rotating it 180 degrees. Okay, that means that you automatically have rotational symmetry, because rotational symmetry is any, okay, it's any rotation. So any rotation gets you the symmetric figure again. Okay. And just as another little note, for point symmetry, it's only 180-degree rotation. So talking about another strategy, okay, the first thing that you should always check for, well, I mean, I say the first thing, okay, you can do line symmetry to check for line symmetry, but in terms of checking for either point or rotational, you should always check for point symmetry before you check for rotational. Always check for point symmetry before rotational symmetry. Okay, always check for point symmetry before you check for rotational symmetry. That way, if it is true that you have point symmetry, then you can automatically tell that you have rotational symmetry. Okay. But if you check for rotational symmetry first, and you're like, oh, well, I can rotate this thing 90 degrees and I get the same shape again, that doesn't necessarily mean that you have point symmetry. Okay, so always check for point before you check for rotational. And note that for point, it's only a 180-degree rotation. So you just flip your paper upside down, you get the same thing. For rotational symmetry, it can be a 2-degree turn, it could be a 30-degree turn, a 45-degree turn, 90 degrees, 180 degrees, any kind of turn, and you get the exact same shape again, that is rotational. And then line, of course, is the one where you can fold the paper onto itself, and you could fold the paper in half and you would get the exact same shape on the other side. Okay, so that takes care of the notes for symmetry. If we take a look at some of these questions, you'll notice that some of them have like multiple answers, right? So if I take a look here at this shape, the first thing that I do is I always check for line symmetry first. So the first question you have to ask yourself is, if I drew a line right here and I folded along this line, would I get the same thing on both sides? And the answer for this one is yes. But that's not the only place that has line symmetry, right? On this shape as well, you could fold right here, going left and right. And that would take this picture. You could fold it from the top down, you get the same thing. Okay, but you have to be careful with doing like this one, right? Because it's not necessarily true. It's hard to tell if you fold it along this guy right here, whether or not you would actually get the same thing on the other side. Okay, but I always check for line symmetry. So these are not the only two lines that you can fold across. For this one, number 3, if I drew a straight line like this, and I folded across it, okay, this one would not work, because if I took, make sure that I put an X here. So if I took this point and I folded across this line, notice that it has a length of this much. I can't pick this up and grab it, but I'll tell you this, I know for a fact that this distance is longer than from this line to here. So if I fold this across, this pink is going to go from here all the way to about right there. So this one will not map onto itself if you fold across this line. If you were to fold across this horizontal line, okay, it would do the same thing. This one's a little bit easier to see because this point right here up in the top right would come straight down like this. It'll be right here. Okay, so this specific one, okay, does not have the line symmetry. But if you were to rotate it, okay, this one would have point symmetry because you get the same thing looking at it upside down. And since it has point, it also has rotational. Okay, up here, this one also has point and rotational because if you flip this shape upside down, you get the same thing again. Now, for the triangle, this one's a little bit different. Okay, we've already talked a little bit about triangles. Okay, so for a triangle, you are going to have the points or the line symmetry here. But if I flip this triangle upside down, it's going to look like this. So it does not have point symmetry. But if I rotate this shape, right, we talked about this in one of our examples, I do have rotational symmetry. So this is one of the cases where you have rotational but not point. Okay, this specific one does not have any because this length from here to here is not the same as this one and this one. So with triangles, something very special happens with triangles. The only two triangles that are going to be symmetric are going to be equilateral triangles and isosceles triangles. Right triangles are not symmetric. Okay, shapes you just have to be careful with. This specific A, okay, is going to have line symmetry because you can draw a straight line, a line straight up and down, and then A is going to map onto itself equally, right? So you have line symmetry, but that's it. It's not going to have point or rotational. This star, you can split it right down the middle. You split it down the middle here, or here, or here, or here, right? Here's our center point. Okay, so we do have line. If you flip it upside down, the star's point would look something like this. Right, so it's not going to have point symmetry, but if I rotate it a little bit less or a little bit more than 180 degrees, I will have rotational. Okay, so a lot of these is just really thinking about the question and what exactly is going on, like just looking at it and thinking about what would happen if you rotated it or folded it. So my advice on answering questions like this is to make sure that you're not just rushing through and clicking stuff just to get through the problem. Make sure that you take your time. Make sure that you actually think about what happens if I fold the shape in half. What happens if I rotate the shape? Okay, and you can do these things with your computer screen, right? Just pick up the screen, flip it upside down for point, and then for rotational, just turn it a little bit to see if you get the same shape again at some point. So that concludes it for this unit. And if you have any questions about anything in the unit, then feel free to message me or send me an email about this. And that's it for the transformations unit.